Okay, so now we have to test the failover scenario in case we lost one of our worker node. So how it will do the auto healing. And the auto healing is most specifically for the scenario where iSCSI is provisioned on a worker node that we discussed in our previous video, and that worker node is down, then what will happen? So let's start by creating. We have this Kubernetes cluster. This is the same cluster I used. I have the same storage class, and I deleted all the previous created deployments and persistent volumes by this storage class. So let me just create a new persistent volume. I am going to create a read write many of 8 GB in the default namespace. So it's a persistent volume claim is created and it's bounded with the persistent volume. So now if we go to our dashboard volumes, so here we can see it's detached, mean no one is using this storage so far, and attached to no this its iSCSI is so far not exposed by any worker node. So when we will attach any pod, then this whole backend process will happen that when the pod will start, it will request to the persistent volume, and on the back end Longhorn will try to set up the iSCSI on some worker node, and then that iSCSI will be provisioned to the pod by using the NFS in case of read write many, and directly in case of read write only. So we discussed this read write many and read write only concept in detail, how it's working. So now let me create a deployment. This is the same deployment. I'm using the persistent volume cream created. It will mount under the Nginx pod with this slash data 4 directory. So we have to apply this and kubectl get deployment get pod. It will take a while to set up because it has to provision the iSCSI and NFS because it's read write many. So let's go to this dashboard. It's attached to this pod, but so far iSCSI it's detached because so far iSCSI is not provisioned. So we have to wait, and now we can see its iSCSI is provisioned, and now it's in attaching state. Attaching mean pod is trying to mount it as an NFS, and it's now perfectly fine. The storage on this worker node as NFS is reachable to this pod. So now we have to look at where exactly this pod is running. It's running on worker node 1, and the storage is also provisioned as iSCSI on worker node 1. So on worker node 1, I'm running lsplk. I can see it's provisioned. So on worker node 2, 3, it's not provisioned. We don't need to run this command. So it's by chance that pod and storage iSCSI is provisioned on the same worker node because this cluster is very fresh. It does not contain any workload, but mostly you will see the storage is provisioned by some different worker node and pod is running on different worker node. So we can test this by kubectl get deployment, and we can scale this deployment replicas to 2, and now get pod, and another pod is it's trying to create on worker node 2. And just to show you one more thing, kubectl execute on this pod tf-h, and it's mounted as NFS. The same thing I will do on the another part. I hope it's provisioned, or is it, yeah, it's provisioned and it's also mounted from the same service. So we discussed all these NFS and iSCSI concept in the previous video. Okay, so now everything is good, everything is working fine. Let's suppose our worker node 1 where the storage is exactly 8 GB is running as iSCSI, and one of our pod is also running on worker node 1. So let me just do the power off to my worker node where storage is provisioned and pod is also running. So the healing of persistent volume is the responsibility of Longhorn engine, and the healing of pod is the responsibility of Kubernetes cluster controller manager. So let's see, after powering off our one of the worker node that was responsible to run one of our pod and our iSCSI storage, what is happening now. So kubectl get pod. So pod is still, I think, running on worker node 1 because it will take a while to relocate this pod to some other worker node because it's not in healthy state right now. And what happened to iSCSI? So if we go to our dashboard, we can see it's in degraded state because one of our node is down, and volume is showing it's in degraded state because its data is not replicating on all the worker node that are responsible to replicate the data. And here the most important thing, we can see the worker node 3 is now responsible to provide the iSCSI storage. So on worker node 3 we run the command and iSCSI is successfully relocated to worker node 3. This is automatically happening as a heal up of our storage. And to the our pod, let's wait for the pod. It will take some time to relocate to some other healthy worker node. So this is done. So here we can see the pod is successfully relocated to worker node 3. This is in terminating state and now it's working on worker node 3. So just to verify, kubectl execute it is pod efh, the storage is reachable. So there the controller manager did the pod level auto healing and Longhorn did the storage level auto healing. So in case we lost our one worker node, our storage and uh, workload, the compute resource is also, the pod is also relocated to the healthy node. So this happen automatically by the controllers. So now you here it's showing 3 pods, but in fact only 2 pods are running. One is in terminating state, and it's showing its state is degraded because the replication in between all the pods, all the worker nodes is not happening to share the data, to replicate the data. Okay, so how it's working on the background, there is a Kubernetes custom resource definition created by Longhorn controller. So here we can see the volume attachment resource is created. It's actually responsible to provision the storage. So it's running on the worker nodes, and Still, it's showing on worker node 1 and in active state, but it will be changed to true to false after some time because it's dead. Sometime in case of failure, we can see that the relocation of iSCSI is not happen automatically. So in that case, we can delete this volume attachment resource from the worker node that was previously providing the iSCSI storage, and it will automatically recreate the new volume attachments resource on the new worker node, and your storage will automatically be provisioned on the new node. So this is just in case you are facing issue of relocation is taking time. So this we test, everything is working fine. Same you can test for your read write once storage. In fact, its auto healing is happening on iSCSI level. So either you are using the read write once or read write many. In fact, the iSCSI is responsible to provide the storage, and iSCSI will be relocated to the healthy node if we lost any of our worker node that is providing the iSCSI storage. So I hope you got the idea. In the next video, we have to understand the volume, the node. If we are in a situation where this storage is not enough, we want to expand it, so we can add more storage in our worker nodes.